So first things first, as always, I'm going to draw on the side. So I'm going to draw a little picture here. And our first vector has a direction of north 72 degrees east. Now this is a quadrant bearing. So we know right off the bat, we're going to have to find our direction, right? A bearing is not a direction angle. Direction angles start from 0 degrees and go counterclockwise. This bearing takes us from the north line 72 degrees in the east direction. So that gives us this vector. Now we're going to call this the boat vector, the B vector. Then we actually have a second vector. We have the water vector. So here it says the water's flowing directly south. Let's do purple. Directly south, meaning it actually is laying along the y-axis. It's laying along the y-axis. Now, it doesn't give us an angle, but if it's laying along the y-axis, what is our direction angle? And we'll call it. Starting, remember, direction angle starts at 0 and go counterclockwise till they reach our angle. What is the measure of our direction angle? For W? Oh my goodness. Okay, you're looking at B. You're totally correct, Matthew. That's how you find the direction angle for B. This portion right here, we know one quadrant is 90 degrees. So to get our direction angle for B, it's 90, take away that 72. And we get how much? Can you zoom in? We are, yes, yes, 18 degrees. Good. This is our direction angle of B. Now, what about what I was asking about was our direction angle of W? So it's from 0. We're going through quadrant 1, which is 90. We're going through quadrant 2, which is another 90. And we go all the way through quadrant 3. Yeah, it's just 270, guys. It's just 270 degrees. Wonderful. So now that we know all this, we can find our two vectors in component form. But really, in number 1, it's just asking for the in component form. So that's what I'm going to do first. First, I'm going to find the component form of our velocity of the boat. Now, in order to take something, a magnitude and a direction angle, and put it into component form of a vector, you take the magnitude, which the magnitude of the boat is how much? Yes, good. 24 miles per hour. Remember, speed equals magnitude. So 24 cosine of our direction angle which we now know is 18. 24 sine of our, so we have 24 cosine of 18, 22.83, and 24 sine of 18, 7.42. So that is the direction angle of the board. I'm sorry. Oh my gosh, that's the component form of the board. And then we are going to find the magnitude and direction of the resultant velocity. That's part 2. Now, in order to do these things, we first do need to know what our component form of the water is. So that's what I'm going to do first. Component form of the water, our magnitude of the water is 10. Cosine of 270, 10 sine 70. Oh, it's the second time I've done this. Okay. 10 cosine 70, which should be 0. And then 10. Before I hit this, before I hit and change this, knowing that the x value of w is 0, can anyone take a guess at what y value is going to be? Remember, magnitude is speed, right? So if this thing has a magnitude of 10, a size of 10, yes, Abby, but we're going on the negative direction of y. Negative 10. Yeah, negative 10. Does everyone see where we could have gotten that from? We know it's lying along the y-axis, right? So our x, it doesn't have an x value. It's not moving left or right at all. So our x value is 0. And we know the magnitude is 10. The size of the vector is 10. So that means from the Pythagorean theorem to get 10, our b value would have to be, our y value has to be 10. And it's going negative, so it's a negative 10. Of course, you can still use the formula if that's like too much for you to put. You can still use this 10 cosine 270, 10 sine 270. Okay, so now that we have our two, now we need to find the resultant magnitude and direction. In order to find the resultant magnitude and direction, we need to know the resultant velocity in component form. So that what we're going to do is we are going to add our two vectors. We first have to add them together. So we have 22.83 plus 0, it's just 22.83. And then we have 7.42 minus 10, it's negative 2 point, does anyone know? 7.42 minus 10. 6.8? 5.8, yeah, 5.8. Close. All right. Now that we know this is our resultant velocity in component form. Okay. Now it wants us to find the magnitude and direction. To find magnitude, we just do Pythagorean theorem based on b value. So the square root of 22.83 squared plus negative 2.58 squared. So square root of 22.3 squared plus negative 2.5. Now, did I really need to put that negative there? No, because I know when I square it, the negative goes away. So the magnitude here is 3.83. So this is actually the speed in miles. That's actually the speed in miles per hour. So that's the first thing it's asking for. And then we find our direction angle. Oh my gosh. Do you guys notice something I did wrong? Or are you just rolling with it? I typed something in wrong. I missed it too. Just rolling. Okay, I knew this was like too small. I'm like, that number is small for this problem. 22.98. 22.98. Then to find our direction angle, remember it's inverse tangent of our B over our A. Oh, so that's inverse tan of negative 2.58 over 22.83 negative 6.45. Now, is this my answer and I'm done? No. Remember, when you're finding direction angles using your calculator, you need to ask yourself what quadrant your vector is in. And remember, I told you that you can think of your resultant vector as for vector. So it's going to be somewhere here, which is in our fourth quadrant. What our calculator actually gave us was this, negative 6.48. Oh gosh. What do we do to this value to get our true vector? Yes, you add 360 to it. You must add 360 because quadrant 4, you always add 360. And you get 3.5. Oh god. And you're done. That is the magnitude of the resultant velocity, and that is the direction angle of the resultant velocity. Any questions on this problem? So there's two ways that you can know what quadrant is. Either look at its component form, right? It goes from 0, 0 to a positive 22.83 on the x-axis, negative 2.58. That would lead you to this vector. Or you can think of it as the average direction between this angle, this vector, and this one. So halfway between is about, right, the first problem on the homework was added 180 because that vector was in quadrant 2. In quadrant 2, we add 180 In quadrant three, we add 180. Quadrant four, we add 360. Right, here it is. This is a problem from the homework. This was a vector in quadrant two. So that's why we did 180. Yes, exactly. All right. Any other questions?